Okay, today our topic is diode application. That is the module 5 in your LMS. Okay, my name is Emmanuel P. Trinidad. Okay, we start our discussion. Okay, there are other diode circuits that are very useful. Some of the diode circuits are limiter, clipper, clamper, and voltage multiplier. Okay, this chapter will tackle these different circuits and show each operation. Okay, we have different types of diode and it depends on the application. These are example clipper, clamper, and voltage multiplier. Okay, we discuss. At the conclusion of this learning module, students are expected to explain the difference between diode limiter, clamper, and voltage multiplier. Then we also analyze each operation of diode circuits. Then we will also discuss bias limiter and voltage divider bias. Then in this also module, we'll discuss voltage doublers, triplers, and quadruplers. Okay, we start. Okay, what is a diode limiter? Diode limiter is used to clip a portion of signal voltages above or below certain levels. Then the reason it also known as clipper, as shown in the figure, is a positive limiter or clipper. It limits or clip the positive part of the input voltage. Okay, makikita nyo, as you can see, means clip, ibig sabihin, ika-cut niya. Kumbaga, ang i-clip niya yung positive part ng input voltage. Then, ang magiging ano na lang is, para siyang nakat, kumbaga nahati. Na-limit yung positive alternation. Kasi makikita nyo sa drawing, meron tayong, for example, positive 0.7 volts is yung nasa taas, yung positive na ano natin, na value ng voltage, is nakat siya. Then, ang natira na lang is yung nasa baba na negative. Okay? Ibig sabihin, diode limiter is also known as clipper. Then, kinakat niya yung positive portion. This is a type of signal is a AC, alternating current. Then, the oscilloscope will show this type of voltage figure or type of sinusoidal wave. As you can see, in the drawing also, it has negative amplitude and negative, and the upper is positive. Okay. Next, we have diode limiter application also. The load resistance RL is parallel to the diode will be limited to positive 0.7 volts when the input voltage exceeds this value. As the input voltage goes back below 0.7 volts, diode becomes reverse bias and appears open. Then the output voltage will look like the negative part of the input voltage with the value determined by the voltage divider formula. Okay. Bago kasi natin makita yung output na sa drawing na negative lang yung lalabas, para maklip yung positive voltage, is yung connection nun is yung RL natin is parallel siya sa diode dapat. Then, para malimit yung 0.7 voltage, input voltage exceeds this value. Pag lumampas na siya ng positive voltage or yung lilimit lang siya, kumbaga, pag bumalik naman siya sa 0.7, hindi pa siya malilimit. Kumbaga, makakat lang is yung saktong nasa positive 0.7 voltage. Then, makikita niyo yung formula natin, yung voltage output is RL, yung load resistance, over yung resistance 1 natin. Then plus RL times yung voltage input. Kung for example, ang voltage input mo is nasa 0.7, yun, multiply mo siya. Then para makuha yung voltage output. Yung voltage input multiply sa RL over R1 plus RL. Okay? Makikita natin yung output is negative lang. Kumbaga, na-clip yung 0.7 volts or na-limit yung positive alternation. Okay, next we have Application of diode limiter again. As shown in the figure, is a negative limiter or clipper. It limits or clip the negative part of the input voltage. As the input voltage goes positive, then the diode becomes reverse bias and appears open. As the input voltage goes negative, the diode becomes forward bias and conducts current. Then the load resistance RL is parallel to the diode will be limited to negative 0.7. Ito naman yung kabaliktaran kasi nga kanina is ang nakakat is yung positive. Dito naman is ang nakakat naman or nakiklip is yung negative na value na 0.7 or na limit yung 0.7 volts. Okay? Ito, as the input voltage goes positive, the diode become reverse bias. Okay? Paano ma-clip yung negative? Yun nga, nagkakameron siya ng reverse bias. Then, nagiging open na siya. Kumbaga, nawawala na yung connection. Then, as the input goes negative naman, pag nag-negative naman yung input, the diode become forward bias. Then, yun nga, nagkakonduct na siya ng current. Kaya yun, makikita nyo lang sa figure or doon sa sinusoidal waveform, ang naklip is yung negative 0.7 volts. Okay? O tinatawag din siyang negative limiter. Yung kanina kasi is, tawag siyang positive limiter. Okay? Ibig sabihin, yung ating diode limiter, it depends kung negative siya or positive yung clip or yung nawala, natanggal. Okay, next we have. Okay, how about bias limiter? Bias limiter is the level to which an AC voltage is limited, can be adjusted by adding a bias voltage or B bias in series with a diode. As shown in the figure, there is value of, as figure of 5.3, this figure is wherein the diode and bias voltage are connected to limit a voltage to a specified position level. Then the voltage at point A must equal to B bias voltage, that is 0.7 volts, to forward bias the diode and conduct current. All in input voltage that goes beyond B bias or bias voltage plus 0.7 voltage is clip off. Okay? We discuss. Dito naman sa bias limiter is nililimit niya nga yung AC voltage by mag-a-add ka ng bias voltage. Okay? In series with diode. Okay? Makikita nyo sa drawing yung ating diode. Then, meron tayong B bias or voltage bias na naka-series with diode. Then, ang diode is, and tsaka yung bias voltage is connected to para maging limit yung voltage natin. Para maging specify yung positive level. Then, makikita nyo dito, yung B bias natin is 0.7 volts is meron siyang nahati. Yung nasa positive na natin na B max or maximum voltage is naging 0.7 volt lang siya. Kumbaga, yun yung nakat. Hindi katulad kanina is positive at saka negative yung nakakat na sa sinusoidal waveform. Okay, the voltage at point A must be equal to B bias plus 0.7. Kung ilan yung bias voltage natin, i-add natin doon sa 0.7 voltage. Then, doon siya magkakameron ng forward bias or magkakandak ng kuryente. Ibig sabihin, doon lang siya mag-start. Pag na-reach na yung 0.7 tsaka yung B bias na value, doon lang magkakameron ng conduct ng kuryente. Then, all input voltage that goes beyond the B bias and 0.7 volts is clip off. Pag lumampas na dun sa value ng B bias 0.7 volts, or for example, ang B bias natin is lang siya, 0.2. Eh di 0.2 plus 0.7, then that will be equal to 0.9. Then, lahat ng mga voltage na goes or lumampas dun sa value ng 0.9, for example, 0.10, is magiging clip off na siya. Okay? Understood? We have a limit that all the voltage goes beyond that 0.9 is clip off. Then below is will be not clip off or still be connect to the current. Okay, next we have, okay, as a discussion, also continuation with bias limiter. As shown in the figure, is positive limiter modified by turning around the diode to limit the voltage to a portion of the input voltage waveform. Then the value of bias voltage is voltage bias minus 0.7. Before, it is voltage bias plus 0.7. Now here is voltage bias minus 0.7 volts. Okay, that is the limit volt, the value. Okay, as you can see, this is the sinusoidal waveform. Then after this bias limiter, the sinusoidal waveform visualize this one, negative 0.7 volts. Okay, I will show the figure. Okay, as you can see, it is a positive limiter modified by turning around the diode to limit the voltage to a portion of the input voltage waveform. Okay, ibig sabihin, pipili lang siya kung anong portion yung kanyang ikakat or ikiklip or ililimit. Dito is ano doon sa formula na above. Lahat ng lumampas na B bias minus 0.7 volts. For example, ang bias voltage is higher kasi yan dapat for example, is 0.9, then minus 0.7, then 0.2 voltage. All above 0.2 voltage, yung will have the limit voltage. Okay, yun yung cutoff niya. Nakalimit yung lahat ng above na voltage dito sa value na to. Okay, next. How about a negative limiter? Modify by turning around the diode to limit the voltage to a portion of the input voltage waveform below. Yung kanina is above naman is yung kanyang ililimit. Dito naman, ang ililimit na voltage is yung nasa baba, below ng negative B bias plus 0.7 volts. Okay? It's called negative limiter. Okay, nakita niyo doon sa figure, yun yung ililimit. Lahat ng below, negative bias plus 0.7 volts. Okay? That is the function of negative limiter. It is a connected series with the diode also. Okay, how about voltage divider bias? What is its function or its application? The bias voltage source of diode limiters can be replaced by a resistive voltage divider that derives the desired bias voltage from the DC voltage, DC supply voltage. Okay, since we have voltage supply, ito yung mga AC natin, or for example 120 volts, then para magkameron ng voltage divider bias or the source is from the bias voltage, then paano ito malilimit? I-replace lang natin siya ng resistive voltage divider. Ito nga yung connection niya. Kumbaga, mag-add ka lang ng resistor para magkameron ng diode limiter, or its function as a diode limiter. Okay, what's the formula to get the value of voltage supply? You just add for example, you have 3 resistance, you add only R2 plus R3 then over R3, then multiply it by the value of voltage bias. Okay, that will be the voltage supply, or the value that will be on the output voltage. Okay, next. How about voltage divider also function as shown in the figure? We have in A, we have positive limiter. This is the circuit diagram. In letter B, in the center, we have negative limiter. And C is in the variable positive limiter. Okay, that is the schematic diagram. Okay, as shown in the figure, diodes limiter are implemented with voltage divider bias. Then the bias resistor must be small compared to R1. Then so that the forward current through the diodes will not affect the bias voltage. Okay, as you can see, yung connection dapat ng ating resistor na gagamitin as a bias resistor is ano siya dapat? Mas maliit compared to R1 para meron siya ng forward current, or meron pa rin ng current connection dun sa diode. Kumbaga hindi maapektuhan yung bias voltage natin. Usually kung ang R1 mo is nasa 1 kilo, for example 2 kilo ohms yung R1 na ginamit mo, resistor 1, then ang connection, ang ano mo dapat, ang bias resistor mo is mas mababa, mga 1 kilo ohms or nasa 800 ohms. Okay? Para hindi magka-affect yung bias voltage. Okay, as you can see in the figure in positive limiter, what's the difference? Only the value of resistance, it depends. Okay, next, or the value of the voltage supply. In letter A, since positive limiter, you should have a supply is positive. Then in negative limiter, the value of supply voltage is negative since it is a negative limiter. Then how about in a variable positive limiter? It's also positive. Okay. Then it only has it's only R2 series with the diode, then R1. Okay. It depends also in the number of resistor that are using. Okay, as shown in the positive also, it has 3. Then okay, the difference between positive and negative limiter is only the voltage supply. Then in variable, it only has 2 resistance, R2 and R1. Okay, that is the connection. Next, we have, how about the application of a diode limiter? Okay, the application of a diode limiter is placed across the input signal path in most digital circuits to prevent the input from exceeding a specific level to avoid damaging the circuit. Okay, kasi yung mga electronics natin na component is meron siya kasing kailangan i-limit natin yan. Kaya gumagamit tayo ng mga mga diode limiter para hindi siya masira yung mga electronic component natin or yung equipment. Kasi mabababa, meron siyang specific na voltage lang yan eh. For example, ang kailangan lang natin is nasa 5 volts or maliit lang na voltage, eh di gagamit tayo ng diode limiter. Lahat ng pag nag-increase yung voltage ng 5 volts is may tendency kasi masira yung equipment natin or magkameron ng short circuit. Kaya ginagamit natin itong diode limiter para ma-avoid yung damaging the circuit or magkameron siya ng short circuit. That's why this diode limiter is placed across the input signal path. Then mga digital circuit kasi natin kailangan mga safe. Usually yung mga sa mga computer natin may mga diode limiter yan para hindi siya masira kung sakaling magkameron ng short circuit yung connection o tumaas yung voltage. Okay, next we have, how about diode clamper? This is another topic. Diode clamper is used to add a DC level to an AC voltage. It is also known as DC restorer. Okay, since diode, we are done with the clipper, we are now in clamper. It means add DC level to an AC voltage. Mag-a-add ka lang ng DC level, kumbaga, para magkameron ng, or tinatawag din siyang DC restorer. Kumbaga, parang yung voltage natin is maging compatible siya or or increase. Okay, these are example of diode clamper. Kinaklamp niya. Pwede siyang tumaas, pwede siyang bumaba. Okay? It depends on DC level. Okay, we have, okay, what's the use of positive clamper? As shown in the figure below is a diode clamper that inserts a positive DC level in the output waveform, as shown in the figure A. The diode is a forward bias, yung connection niya. When the input voltage initially goes negative, then the capacitor charged to near the peak of the input or BP input equivalent to -7 volts. Then the diode is reverse bias after the negative alternation. Okay? Okay, as you can see, clamper. Positive clamper, nag-i-insert siya ng positive DC level. Makikita niyo siya sa yung A natin is yung naka-forward bias when the input voltage initially goes negative. Then the capacitor charged to near peak of the input voltage. Okay, makikita nyo is nag-clamp. Nakita nyo sa drawing is ito. For example, dito sa letter B, ang B kasi is ano siya, yung kanyang nagkameron siya ng additional na DC level output waveform. Kumbaga kung dito, sinusoidal, is meron lang siyang pag-ganon, then nagkameron siya ng isa pang BP, or that is equivalent to 0.7 volts. Then ang connection ng diode sa A is naka-forward bias when the input voltage initially goes negative. Ibig sabihin, kapag nagkameron ng yung input voltage natin is pumunta siya ng negative na or negative value na, dun pa lang siya magkakameron ng forward bias or magkakameron ng connection yung ating current or gagana na siya. Okay, ganun lang siya. Makikita nyo. Okay, how we are done with the positive DC level or positive clamper. How about the negative clamper? Okay, it's a continuation also. Positive clamper, the capacitor only discharge through the high resistance RL, then the capacitor discharge very small amount from the peak of negative half cycle. Then the clamping is affected if the capacitor discharge during the period of the input wave. The clamping is excellent if the RC time constant is 100 times the period. Then the capacitor voltage acts as a battery in a series with the input voltage. Then as shown in the figure, B is the DC voltage of the capacitor adds to the input voltage by superposition. Okay, these are the example of positive clamper operation. Ang function lang kasi ng capacitor is mag-store siya ng energy or yung current. Dito, ang capacitor is magdi-discharge siya through high resistance. Kapag nagkameron ng sobrang taas ng high resistance sa RL, doon pa lang siya magdi-discharge. Kumbaga magbababa ng value ng current. Ibababa niya kasi nga nagkameron ng high resistance. Ang high resistance kasi yung RL is nire-resist niya yung current. Kaya ganyan ang ginawa ng capacitor, nag-discharge siya. Then, ilan yung dinischarge siya? That is very small amount ng peak of the negative half cycle. Kaya makikita nyo sa ano is meron siyang kilamp. Kumbaga, kilamp, tinaas niya ng value. Then, the clamping is excellent if the RC times constant is 100 times the period. Okay, ano ba yung RC times constant natin? Ito yung tinatawag nating resistor tsaka capacitance. Kumbaga, yung clamping natin is masasabi natin siyang okay, nag-clamp siya is kapag 100 times the period yung value niya. Then, the capacitor voltage acts as a battery in series with the input voltage. Okay, ang function naman ng capacitor voltage dito is nagiging battery siya na naka-series with input voltage as shown in the figure B. Okay, ito yun. Makikita nyo, ito yung capacitor natin. Naka-series siya sa input voltage dito sa AC. Okay, that is the schematic diagram to have this called positive clamper. Okay, next we have the positive clamper. Makikita nyo dun sa ano kasi, di ba, dun sa una nating visualize na sine wave is naka-sinusoidal siya na 360, then makikita nyo siya. Kaya positive clamper, tinaas niya. Nakita nyo yung zero, nandun na siya. Oh. Pero ganun pa rin siya, may 360 pa rin siya. Then, yun nga, clamp niya pataas, papunta sa positive. Okay, next. Okay, how about negative clamper? Sa negative clamper, kung sa kanina is positive yung kinaklamp natin para pataas, sa negative clamper naman is ibababa naman natin siya, ilalagay natin siya sa negative na figure or negative coordinate. As shown in the figure, it's a diode clamper that inserts a negative DC level in the output waveform. Ayun nga, nasa negative DC level na siya, output waveform. Then notice that it is a positive clamper with diode and a capacitor both turn around. Okay, makikita natin. Ito yun. Ito yung sinusoidal natin. Then, dun lalabas sa visualize is nasa negative na siya. Yung 7.7 voltage natin na positive is nandito siya sa may 0. Itong 0 na to is 0.7 voltage siya. Then, dito siya mag-start. Okay? Ibig sabihin, kilamp natin siya papunta sa negative na coordinates. Okay? Familiarize with this connection. The negative clamper, BP, the capacitor and the diode is series. Next we have okay, we are done with the clamper and clipper. We will now go with the voltage multiplier and voltage Doppler. What is this function? What are their function? A voltage Doppler is a voltage multiplier that produces an output voltage from the input voltage with a multiplication factor of 2. Ibig sabihin, minumultiply natin or pinapadami yung value ng voltage. Ito yung gamit ng voltage Doppler. Okay? Nagpo-produce siya ng output voltage from the input voltage with a multiplication factor of 2. For example, ang natin is input is 5 volts. Then magiging 10 volts siya, times 2 lang siya. Ito yung voltage Doppler. Okay, what's next? How about half wave voltage Doppler? As shown in the figure, is during the positive half cycle of the half wave voltage Doppler, the diode D1 is forward bias and D2, diode 2, is reverse bias. Capacitor 1 is charged to the peak of the secondary voltage BP less than the diode drop. Okay. Makikita nyo sa figure natin, ito nga yung positive half cycle na half wave voltage Doppler. Then the diode D1, kasi yung D1 natin is siya, forward bias yung connection. Then dito naman is naka-reverse bias. Then capacitor 1, yung capacitor natin is charged to the peak to the secondary voltage BP less than the diode drop. Okay? You just follow this schematic diagram in order to have a half wave voltage Doppler. Okay, next we have, as shown in the figure, is during the negative half cycle of the half wave voltage Doppler, the diode 2 is forward bias, then D1 is reverse bias. Then capacitor 1 can discharge. Then the peak voltage on capacitor 1 adds to the secondary voltage to charge C2 to approximately twice nung voltage peak natin. Applying Kirchhoff law around the loop. Okay, Kirchhoff law, familiarize mo naman kayo dyan, is the summation of current across that loop. Then, ang equation natin, voltage capacitor 1 minus voltage capacitor 2, then plus peak voltage equivalent to 0, then we will get now the value of capacitor 2 equal to capacitor 2 plus BP. Okay. Then neglecting the diode drop of diode 2 equivalent to voltage capacitor 1 equivalent to voltage peak. Okay, formula lang din naman to. Susundin lang natin. Then, kung paano nakuha yung voltage capacitor 2 is equivalent to twice nung peak voltage niya. Okay? Kung i-ano natin tong formula na to, yung voltage capacitor 2 tsaka equal to voltage, twice ng voltage peak, makukuha natin tong value dito eh. Yung sa value ng voltage capacitor 2. Okay, next. How about full wave voltage Doppler? As shown in the figure is during the positive half cycle of the full wave voltage Doppler, the diode 1 is forward bias and capacitor 1 charged to approximately yung peak voltage natin. Since yung kanina is half wave lang naman yun, kumbaga kalahati lang yung equation natin or yung schematic ang ginagamit. Dito naman is full wave voltage Doppler na siya. Kumbaga, ano na siya, isang buo na. Kumbaga, meron siyang positive half cycle ng full wave voltage Doppler ang ginagamit. Okay, that is the schematic diagram. We have here the transformer, then we have capacitor 1, capacitor 2. Then the connection is in the reverse bias. The diode 1 is forward bias, then and capacitor 1 charged to approximately peak voltage. Okay, next. As shown in the figure, during the negative half cycle of the full wave voltage Doppler, the diode 2 is forward bias and capacitor 2 charged to approximately BP. Then the output voltage, twice ng peak voltage, is taken across the two capacitor in series. Okay, that is the negative half cycle naman. Yung kanina positive half cycle ang ginamit. Ito naman is yung negative half cycle na ng full wave voltage Doppler. Okay? So dito is yung diode 2 niya is naka-forward bias. Then capacitor 2 is magcha-charge siya. That is approximately 2 BP. Okay, next we have, how about the voltage tripler? What is the schematic diagram? As shown in the figure, is a voltage tripler that is created with the addition of another diode capacitor. Nag-add ka lang ng isa pang diode capacitor section to the half wave voltage Doppler. Okay? During the positive half cycle of the secondary voltage, capacitor 1 charged to peak voltage through diode 1. Then, during the negative half cycle naman, ang capacitor 2 naman is mag-charge siya to twice nung value ng peak voltage through diode 2. During the next positive half cycle naman, yung ginagawa naman yung capacitor 3 is nag-charge siya to twice nung peak voltage, then through diode 3 doon siya dumadaan. Then, ang output voltage naman natin is magiging ano na siya, 3 BP or 3 beses nung peak voltage is taken across capacitor 1 and capacitor 3. From the word itself naman, voltage tripler, ibig sabihin, ang output voltage natin is magiging 3 beses nung peak voltage natin. Yun nga, kaya ginagamitan siya ng ilang capacitor to, 3 capacitor din yung gagamitin natin. C1, C2, at saka C3. Then sa diode is meron tayong dalawa, D1 at saka D2. Then yun nga, during yung positive half cycle nito or nagkameron na ng connection ng ito sa positive half cycle, yung secondary voltage natin tsaka yung capacitor 1 is magcha-charge siya to BP. Okay, that's the connection or the application. Then ang magiging output lang nito is 3 beses nung 3 BP natin, nung peak voltage. Okay, next we have, how about voltage quadrupler? Kung kanina is tripler, 3 beses yung peak voltage niya. Dito naman is magiging 4 na beses ang equivalent nung peak voltage. Okay? As shown in the figure, is a voltage quadrupler that is created with the addition of another diode capacitor section to the half wave voltage tripler. Yung half wave voltage tripler natin kanina schematic, mag-add ka lang ng additional na diode capacitor section. Then during the positive half cycle, ito yung function ng secondary voltage. Then ano mangyayari? Yung capacitor 1 natin is magcha-charge siya to BP through diode 1. Then yung during negative half cycle naman yung kabila niya, yung capacitor 2 is magcha-charge siya na maging 2 BP then through diode 2. Then during the next positive half cycle naman uli, yung capacitor 3 naman is magcha-charge siya to 2 BP through diode 3. Then during the next negative half cycle, yung capacitor 4 na magcha-charge siya to twice nung BP through diode 4. Then para pagsama-samahin lahat na tong mga application o yung kanyang ginagawa is magiging ang output niya is magiging 4 BP na. Then dito ay makikita natin dun sa capacitor 2 at saka capacitor 4. Okay? that this is the voltage quadrupler schematic diagram. Okay?